Hey everyone, welcome back to the Forge. Today we're turning an old automotive timing chain into a Damascus-style knife. Timing chains are high-carbon steel, perfect for knives. We need to forge weld all these links into a solid billet. First, welding the chain links together so they hold. Using MIG welding, just tack welds to keep them in place. Knock off slag with a chipping hammer. It can create weak spots. Subscribe to my channel so you don't miss new life hacks. Into the forge at around 1200 degrees. Just consolidating the mass, not welding yet. Watch the color. Yellow glow is ideal. Hammering with a cross-peen hammer directs the flow of steel. Each strike is deliberate. Think sculpting with sparks. Applying borax flux. It melts around 740s and protects steel from oxidation. Dissolves scale so clean, steel touches clean steel. Tip: mix with water to make a paste. It sticks better than dry powder. Back in the forge to get it up to welding heat, around 1300 degrees C, 2370 degrees. That's a bright yellow, almost white at the edges. This is where the magic happens. Now I'm using the hydraulic press. Why a press instead of a hammer? Control. A hammer delivers impact force, which is great for shaping, but a press applies steady, even pressure. If you see sparks shooting out the sides, that's a good sign. It means the layers are fusing. Pro tip: don't press too fast. Let the steel do the work. If you rush it, you'll trap cold shuts. Unwelded layers that'll ruin your blade later. Patience, grasshopper. Grinding off the scale. That black flaky crust is iron oxide, basically rust formed at high heat. It's hard, abrasive, and will ruin your grinder belts if you're not careful. I'm using a 36 grit flap disc on an angle grinder. Coarse grit cuts fast and doesn't clog as easily. Keep the grinder moving and don't dwell in one spot, or you'll create low spots. Safety glasses are a must. Those shards are sharp. Now I'll stack the two pieces and weld them together. Each fold doubles the layers. One fold equals 2, 2 folds 4, 3 folds 8. Tack welding the pieces together, just enough to hold them. Then back into the forge for more flux. You can never have too much, but too much makes a mess. Hammering again sets the weld. I work from the center outward to push out trapped air and impurities. Starting from the edges traps everything in the middle and ruins the weld. Back to the press, applying steady pressure to consolidate layers. The billet grows longer and the layers merge nicely. Watching this happen is satisfying. One of the best parts of forging. Heating the billet again to twisting temperature. Twisting creates that signature Damascus pattern with swirls and waves. I clamp one end in a vise and twist with a wrench on the other end. The steel must be at forging heat, around 1200 degrees C, or it will crack. High-carbon steel is brittle when cold. About 3 per 4 full rotations give a nice, visible pattern without overdoing it. No twisting wrench? Weld square stock to the billet and twist in the vise. Cheap and effective. The pattern is starting to emerge beautifully. cutting off the twisted ends, which are always a bit wonky. Uneven twisting or cold shuts would ruin the knife. Back to the press to flatten the twist. As the billet flattens, the layers spread and create organic, wavy lines. High and low carbon layers contrast sharply. This is the point where the Damascus pattern really starts to show. Later, acid etching will enhance the pattern even more. It's physics, heat, and a little magic all at once. Back in the forge to shape the rough knife profile, hammering the tang narrower, leaving the blade thicker. Using a flat face hammer now for smoothing. Crosspeen was for moving metal earlier. Keep hammer strikes consistent in angle, force, and rhythm. Uneven strikes create uneven thickness. That leads to warping during heat treatment, which is frustrating to fix. Each strike matters, and patience is key. The knife is starting to take shape. All right, now we're grinding, and grinding, and grinding some more. Welcome to the least glamorous part of knife making, material removal. This is where you earn your beer. I'm using an angle grinder with a 40 grit flap disc to rough out the blade shape. I've marked the profile with a marker. Yes, a Sharpie works fine. And I'm grinding down to the line. Keep the grinder moving. If you stay in one spot too long, you'll overheat the steel and ruin the temper. Even though we haven't heat treated yet, localized overheating can cause stress fractures. Not good. I'm switching to a finer grit, 80 grit, to smooth out the rough grinding marks. You want to remove the deep scratches left by the coarse grit. Why? Because deep scratches are stress concentrators. They're weak points where cracks can start. Blacksmith life hack. Use a file to check your bevels. A file will skate over hardened steel but bite into soft steel. If your file skates, you've overheated that spot. Time to grind it back and start over. Fun times. Drilling holes for the handle pins with a 5mm drill press. Precision is key. Holes must be perfectly perpendicular. Use cutting oil to lubricate, reduce friction, and prevent overheating. Drill slowly, high pressure, low speed. Crooked holes mean crooked pins, which ruins the handle. A hand drill won't give the same control. Patience here ensures the handle fits perfectly later. Every small detail matters. Cleaning the blade of dust, oil, and grime with a wire brush and acetone. Blade must be spotless before heat treatment or defects appear. This step is boring but critical. Any grease or dirt will carbonize during heating. Professionals never skip this step. Even though tedious, it makes the next step safer and more predictable. I check the edges for irregularities. Everything looks good so far. Heat treatment. Heating blade to critical temperature, around 800–820 degrees Celsius. High carbon steel changes structure to austenite. Quenching in used engine oil rapidly transforms it to martensite, super hard, brittle steel, then sand quench for gradual cooling to lower residual stress. Magnet test confirms critical temp. If the magnet doesn't stick, it's ready. Post-quench, the blade is covered in oil, carbon, and scale. Scrub it off with wire brush and abrasive pads. Check for cracks along spine and edges. Any irregularity means starting over. Luckily, this one is cleaned. Blade remains straight with no warping. Cleaning also prepares it for etching. The surface must be perfect for pattern to show. Acid etching with ferric chloride brings out Damascus pattern. High carbon areas etch darker, low carbon lighter. Dip 5 to 10 minutes. Check periodically to avoid over-etching. Rinse thoroughly and neutralize with baking soda. The pattern starts to pop beautifully. This step is the reveal, the wow moment. Seeing those layers come alive is rewarding. A little chemistry makes steel look magical. Time to make the handle. I'm using a nice piece of hardwood. Looks like walnut or maybe mahogany. Dark, dense, and classy. First, I'm drilling holes for the pins. These need to line up perfectly with the holes in the tang. I'm using the tang as a template, clamping it to the wood and drilling through the existing holes. Easy. Now I'm shaping the handle scales with a belt sander. I'm going for a comfortable, ergonomic shape. Slightly tapered, rounded edges, no sharp corners. A knife is only as good as its handle. If it's uncomfortable, you won't use it. Pro tip: sand with the grain, not against it. Sanding against the grain creates scratches that are hard to remove. With the grain, the scratches blend in and disappear with finer grits. Apply two-part epoxy to tang and scales evenly. Insert pins flush. They compress for a tight fit. Avoid excess squeeze-out. This step is critical for durability. Now comes the tedious part, shaping and polishing the handle. I'm using an angle grinder with a flap disc to rough shape, then switching to finer grits for smoothing. You want the handle to flow seamlessly into the blade. No sharp transitions, no gaps. It should feel like one continuous piece. I'm working through the grits, 80, 120, 220, 400. Each grit removes the scratches from the previous grit. It's slow, it's boring, but it's necessary. After sanding, I polish the handle with a buffing wheel and some compound, which brings out the natural color, highlights the grain, and slightly seals the surface against moisture and dirt. I check every curve, feeling for smoothness and comfort, because an uncomfortable handle ruins even the sharpest blade. Finally, I apply boiled linseed oil or tung oil. It penetrates deep into the wood, protects it, enhances the grain, and gives a beautiful, natural sheen. Plus, it's food safe, so this knife is ready for both display and kitchen use, combining function and aesthetics perfectly. Sharpening. Belt grinder. 220 320 grit to shape bevel. Then 1000 grit whetstone for polish. Hold blade at 15-20 degrees angle. Lower angles sharper, higher angles stronger. Paper test checks sharpness. Clean slices confirm edge. Take time to refine. Rushed sharpening hurts precision. Sharp blade is safe and effective. Always test carefully. Damascus blade from timing chain, hardwood handle, brass pins. Key points: high carbon steel, borax flux, hydraulic press, twist pattern, oil quench, ferric chloride etch, careful handlework. Subscribe and comment for more junkyard blacksmithing. Share your results, successes, and fails. Seeing the final piece is rewarding. This knife shows patience, skill, and a little madness.